What is this? Another one. Thought you were saying no to these cars. Oh, it's your beach connection. Yeah, I guess you gotta say yes to this guy. What's he want done with it?
The turn signal switch is all wonky inside, so it shuts all the lights off.
Gotcha. So we doing some wideband O2 stuff today?
I believe so, as long as it's still acting up. I don't know if it's got to do it. I forgot about it. When she came in,
you already got a sensor for it. And
I have one.
What our community doesn't know is, well, but I don't know either, is what are we working on?
Honda Accord.
So Honda Accord, my brother, here's what we're doing, some wideband O2 testing. And what my brother had done before today is he confirmed the upstream O2, which is a wideband. It was indicating a lean condition, and what he noticed was the downstream O2 was pegged rich, and we had 10% tailpipe CO emissions. Now, a lot of you guys don't have emission analyzers. My brother still does have one here, one of the few garages in the entire area that has a working one. He confirmed a sensor that was lying. So you guys have heard me use that term a lot, a lying O2. And so what we're gonna try to do is recreate this situation, show you guys what he saw, and then talk a little bit about some of the testing methods we can use for wideband sensors. Ta-da! Using my safety glasses with readers. I'm so happy to have these. My family's been making fun of me because I've been wearing them in the house. I'm watching TV and I'm working on the computer. I got my safety glasses on.
Never be too careful.
Yeah, man, I'm always gonna have safety glasses on now. I'm really not worried about a full code scan for this. I'm just going right to the engine computer. PCM is my guy. For what we're doing here, engine computer's fine. We don't need to do a full system scan, and this thing's taking forever as it is. I would imagine we'd be here for a long time for a full system scan. All right, so we'll go trouble codes, see what we have. I think my brother had mentioned, yeah, P0171, and I was gonna say 174, but this is a single bank system, I think. We also have a 420 code, a catalyst efficiency code. One of the things that you don't want to ever do is be too worried about a catalyst code when you have other fuel related codes, or really any drivability type conditions. You want to fix those first before you would ever attack a 420 code. I'm not going to worry about that. We'll make sure Danner knows. The 171 code says fuel metering too lean, and I'd like to see my freeze frame data on that. All right, so this is the freeze frame data of the 171 code. What I'm interested in is my fuel trim, and then also the upstream and downstream oxygen sensors. Upstream is a wideband, downstream is a regular zirconia narrowband. So that's showing us 0.55, and our AF sensor, they're indicating that as 0 milliamps. So one of the things we're gonna be talking about with this wideband sensor is its operating range, which, if I remember correctly, is somewhere between 2 and 4 milliamps. So we're talking a tiny number, which is really why people have so much trouble trying to measure these. They don't operate the same way as narrow bands, and you're talking about a swing of 2 to 4 milliamps. Just not going to see that with conventional equipment. I mean, we had a hard time doing a parasitic drain the other day, just reading 150 milliamps. Imagine trying to decipher between 2 and 4 milliamps of current. Just not going to happen without some specialized equipment or some adapters and some things you can do, like with wrapping a wire around multiple times with your amp clamp and stuff like that. But I think we'll have a chance to talk about that. This isn't really helping me. This happened at idle, 165 degrees. I'm just gonna go to my live data. So 1.6 amps on the heater. I wonder why that's red. Let's watch our downstream sensor, which is this guy right here, HO2S2, and then our AF sensor milliamps, this top value up here. Now, one of the things that we can do when we see data that's unfamiliar to us, especially when it comes to wideband sensors, is we can use global data, which I may switch to, because these trim numbers are different range than what I'm used to. And I don't know if that's a min-max scale or that's the spec, like the range for this. I believe that you can interpret these numbers, the short term and long term, as 1.0 being 0. Then you see the range is 1.5 and then 0.5. I'm pretty sure that that's how you use that number. And I think lambda is the same way, as 1.0 is 0. And numbers above is lean, numbers below is rich. And the fuel trim would be similar to what we're used to. So 1 being 0, numbers above 1 is adding fuel, numbers below 1 is taking fuel away. Right now this looks clean. It looks like it's working like it's supposed to. You see the range on the AF sensor up top. It's showing minus 1.4 to positive 1.4. So you're talking about 2.8 milliamps is the operating range of this sensor. So it shows the range of 0.8 to 1.2. The reason that's red is that's outside of the range that they're giving you on a normal operating sensor. That's not a problem. I know that for sure on oxygen sensors, but that's why that number's red. Just familiarizing myself with the tool. It stinks now. You smell it?
Yeah, I do.
It just changed on us. Notice the downstream sensor is full rich right now. And notice our short term and long term are both adding fuel, numbers above 1.0. So we're at 1.47 and 1.25. My lambda is 1.54. So that's indicating lean. So it's opposite. That's where Danner's calling the Wideband O2. So this upstream sensor right now, yeah, it had to be hot to act up, but this upstream sensor and then the downstream, 0.94, downstream's full rich. Upstream, I believe, I'm reading the lambda correctly, 1.54 is very lean. And then we're reading a minus 0.8382 value. Let's see if we can make this move. I'd like to drive it to get into a decel fuel cut mode and see how the sensor reacts. I'd also like to add fuel to this. See, I can get it to react. There was a positive 2, or no, that's even more lean, isn't it? Yeah. See, I can't drive it rich. It's staying in the minus range, so I should be looking, sorry, I was looking here. I was looking at the lambda. That's pretty much telling you a full lean condition upstream. Now let's focus on the AF sensor now. Minus numbers should be lean. So if this is a wideband sensor, I'm doing the same thing. I'm trying to force the sensor rich and lean to see its reaction. I can clearly see my downstream down here is full rich, 0.92, and my upstream right now, I'm assuming that number, that minus 0.83 milliamps is full lean, and I should be able to rapidly snap the throttle. I can't drive that rich, and honestly, that's enough information for me and for my brother too, along with the heater current for the, oh, that's the downstream heater current. That's why that number seemed low to me. I was gonna say, along with the heater current value being on the scan tool, there's really no other checks that I feel like need to be done. We're gonna do a couple anyway. This stinks real bad.
It smells terrible.
Real bad. This is an absolute full rich condition. Let's go up and get a tailpipe reading. I wanna show you guys another method to identify oxygen sensors that are lying. Is that, and basically what's happening here is the upstream sensor is telling the computer we're lean, and the computer's adding a bunch of fuel. It is fuel that is not needed, and so we have an extreme rich condition right now. This is the kind of car, you gotta be careful. If you're in a shop and it's wintertime and you're not putting an exhaust hose on the car, you literally have 10, 15 minutes of runtime can put enough carbon monoxide in the shop to kill you. So pay attention to what you're doing. I had a friend that had this exact scenario, and I'm talking to him on the phone, telling him how to identify a lying O2. And by the time he was finished talking to me and doing some tests, he had a technician that almost passed out in the back of his shop. He was taken to the hospital in an ambulance, and my friend was also very sick. So you don't want to fool around with stuff like this. Very, very high COs going on right now. That's what Caleb and I are smelling. Woo! Stinky. It's so bad.
It's really bad.
It's real bad. I'm gonna leave this outside. Gas calibration, manual gas testing mode. Nice. Watch my CO2 when I breathe out. Ready? I don't know why I showed you that. This will be the number we're really going to be focused on for this is the CO. Watch when I put this in the tailpipe. It's going to be a little bit of a delay. Look at that. That's death right there, brother. 10% CO. There is no way that that O2 sensor, that we have a lean condition. So the code was what? 171, right? It's a lean exhaust. It's telling you, well, a lot of people are gonna want to change an oxygen sensor for this. In this case, you would be right. But in a lot of circumstances, vacuum leak, low fuel pressure, restricted injectors, mass airflow problems, all would give you lean conditions. What we have is a false lean condition. That is what this 10% CO number is. I want to point you guys to a lecture that I've done on tailpipe gases for using tailpipe gas as a guide to whether or not that O2 is lying. If an O2 sensor's lean, is indicating lean, and your tailpipe COs are 10% like we have here, sensor's definitely lying. Wideband, narrowband, doesn't matter. You got an O2 that's reading full lean, what do? Add fuel, see if it reacts. How do you add fuel? Flutter the pedal like we were in the parking lot. Grab propane, put it in the intake. Manually make the mixture rich. In our case, we don't need to do that. 10% CO, we already know it's full rich. We also know the downstream O2 indicating full rich while the upstream's full lean is an indication we're in the same area of a faulty O2. Adding fuel is not what we need to do with this car. All right, I just merged these two graphs, the upstream sensor and the downstream. You see the downstream is 0.98 or 1 volt full rich, and the upstream is minus 0.5 milliamps. Again, snap the throttle. I should be able to drive the downstream lean, as you can see, lean and rich during deceleration. So when I snap the throttle, let off, during the decel, there's fuel cut. So fuel cut is when we shut the injectors off, and that's what drives the O2 lean, and you see that downstream react like that. Now, it shouldn't be if the cat is efficient. You know, we shouldn't really have that kind of response on the green trace, but because the cat is potentially also damaged here, we have a 420 code, that's why the downstream's so reactive. But what that shows you, regardless of the cat, is the sensor is able to produce in the full range of rich and lean. In other words, it reacts to rich and lean. And then we watch the blue trace now too. We really, it has some reaction to it. But I'm never going over like minus 0.3. And when I snap the throttle and make this go full rich, I should at least get up to like the 1.4 milliamp range. Let's go for a quick test drive and I'll show you. So this test drive, just wanna get a longer period of time where I'm at wide open throttle than I can hold in park. Just wanna watch this. Really the upstream again, the AF, the milliamps. That stayed lean. That stayed lean the whole time. This sensor's just not reacting. We just need to make sure that wiring wise we're okay. First gear, wide open throttle, and then let off. Best of both worlds. Full rich, which we should have right now. Still wide open, and then let off. And there's your decel. And how do I pause this? I'm sure that in the video, you're gonna see this, Caleb, that when I was test driving, of course, we were rich on the downstream already, so seeing a difference from what we were, you know, it didn't change. But we did see when I let off, we saw the downstream drop. We actually saw the upstream do the same, but I couldn't drive the upstream rich. Use that method, guys. It's still valid. Doesn't matter that it's a wideband sensor and they operate off milliamps instead of millivolts. Doesn't matter. Doesn't matter, same stuff. This sensor is just dead here. And I think rather than, did Danner want us to go in the shop? Did he say he wanted us inside?
I think he said that as a joke. Because of the carbon.
Oh, he wanted me to run it in there so he falls over. Let's go hear from him for a second. There's one other thing I can show you guys. If there was some confusion on the data, let's go global. I mentioned that. Let's look at some global data real quick. Start this back up. I do have a hose on it. I was just looking to see if there was a heater indication for the upstream sensor, and I don't see one. Yeah, the air-fuel ratio is like indicating, that's this one right here, is indicating like 18:1, which is super lean. It's definitely not. These are calculated based off that front sensor. We're adding a whole crap ton of fuel. Our short term is pretty much buried. So the point I was trying to make with you guys is you're not familiar with the data. I'm not either. I mean, a little bit, maybe more than some. But 1.47, what's that mean on the short term? 1.25, what's that mean on the long term? And then also for the front sensor, that milliamp reading, what's that mean? Well, let's get out of here and we're just gonna go global. And then what I'm looking for is my live data. And yeah, nice. So our short-term, long-term trim are now numbers we're more used to looking at. And bank 1 sensor 2, bank 1 sensor 1, they're still giving me current here. As far as the sensor goes, the milliamp number is still being shown, the same we had in the factory mode, but it's nice to see the fuel trim numbers, the 46.9 and 25% positive. So right now we're at like 40, 50, 60, 71% overall adding fuel. So 46.9, remember that, 46.9 and 25. Now let's go back. I know how to use the decimal point numbers now. Remember we were at 1.25 long term and 1.46 short term. Well, what's the 0.46? 46%. What's 1.0? Exactly what I told you guys. 1.0 for the Honda data is 0% fuel trim. 1.46 is positive 46%. 1.25 is positive 25%. And how do I know that now? Because I use global data to help guide me. Remember that. You got unfamiliar data, especially when it comes to widebands. Jump over to global, see what you have. Now we could make the argument here that the heater circuits malfunction, so we want to check that. These wideband sensors need to be very, very hot to work, like twice the amount of a narrowband. Narrowbands are like 600 degrees, a wideband's like 13 to 1400 degrees. So exhaust may not be enough to heat a wideband sensor, so we want to make sure the heater's functional, and then a couple of quick circuit integrity tests before we change the O2. That's my goal. Wiring and how getting to it is going to dictate what we're going to do. I really feel like I have enough info to put an O2 in this, but we should cover our bases anyway. Let's look at those two guys right there and right there. So 1.47, what did global mode say for the short term? 46 point something, right? Yeah. So I'm at 1.47. What's that mean? 1.47 is 47% positive trim. Yeah. 1.25 on the long term is positive 25%. So that's where we're at. Computer's adding a whole bunch of fuel. Now, why would it be doing that? Because the upstream sensor is indicating lean, minus 0.44 of an amp. It's lean, and how do I know that? Well, look at the downstream. Downstream is choking full rich, and our gas analyzer confirmed we are indeed full rich. Downstream is accurate. You can use your downstream to gauge the upstream. This is a faulty upstream O2 wideband, faulty. We'll do a couple final checks to be sure it's not wiring or heater. But yeah, this is real basic. A lot of people are afraid of wideband sensors. There's no reason to be. You want to get a shot from here on this side straight down, Caleb.
What did you do?
Burnt myself. That's where our sensor be. It's nice and hot. Way to go, Danner. We'll do all of our checks on the harness side of the O2 connector because I'm going to be poking holes. Then we won't have to worry about sealing them up. I'm like, why is everything so blurry? Because I'm using readers and I'm trying to see a distance. Dumbass. All right, can you see those colors? Yep. Two blacks, a white and a blue. The two blacks are the heater circuit. When you have two of the same colors, that's the heater. And then you're gonna have a signal and then a signal ground for the other two. I'm not sure if it's white or blue. We'll go after the heater circuit first. I'm using my Phil's electrical probe, and this engine's super hot. I'm gonna get burned.
So which wire are you going on?
One of the blacks. Just confirming heater circuit operation. You can use an amp clamp on that. I don't have one with me. We're just doing voltage measurements. The Autel will communicate with the scope module remotely. Like, you don't need it to be plugged in to the data link connector to talk to the scope part. It has built-in Wi-Fi. So if I couldn't reach, I can take the data link connector off. This stays powered up. It has a battery in it, and I can still use the scope and communicate with my scan tool. When I first started using this, it was one of the complaints I had was the fact that I had to stay tethered, and you don't. Let's go back, and we want to go to measurements. We'll use the oscilloscope. There's a 4-channel scope, just using channel A. All right, so I set this up to 500 millisecond per division. No particular reason I picked that one, just we're doing quick heater circuit check, and I may adjust it from there. I am connected to battery positive, so you can see we're at 12.4 volts. Take it off, right? We're at 0. So I know my scope reads going right to this lead, and with the key on that terminal, that black wire, I'm reading 12 volts. I'm gonna start the car, see what it does, because this could be a ground side switch circuit. I don't wanna say right off the bat that that's the battery feed for the heater. I need to see what this does. Yeah, we got some spikes in here. Let's lower this time base to make sure. Yeah, those are just electrical noise. I can see some square waves kind of in here. That's showing me some pulsing going on, probably on the other wire. Ignore the spikes. We're reading battery voltage on that one with some indication of current flow. Those smaller little square waves that are on top of that. I'm gonna switch this to the other black wire. Yeah, the one we are currently on, that we just measured, we'll call that heater positive. Switching over to the other black wire, this should be heater negative. Yeah, pulse width modulated ground is what that is, and those little square waves that I was talking about, we could see on the positive line, that was current flow as the ground was being energized. So that's a pulse width modulated ground. Computer is controlling this heater like it should be. I am not worried about electrical wiring for the heater. Again, you could do current measurements on this if you wanted to. I do not have an amp clamp for this Ultra kit, so I'm not gonna do that. I'm comfortable with those readings. Final two checks, see what we got. See if they're using some kind of a bias voltage on this. Remember, it's gonna look different than the scan tool. Scan tool is giving us a milliamp reading. We're actually gonna be measuring voltage now. Do the white wire first. Yeah, I'm reading a voltage of around 2.5 volts. I can throw in a min-max number there. Oh, it's picking up those spikes. That's not good. Let's turn that off. We'll go DC average. So about 1.7 volts on that wire. That's the white one. And then last one will be the blue wire. This is sensor side. So if you guys are looking at wiring diagrams, figure out which wire I'm on. It's not gonna help you. Sensor side colors change. And this one's reading 2.2 volts. And so difference in potential between those is really, what the computer is using for amperage measurements. 1.7 on one and 2.2 on the other. I'm comfortable with these numbers. The fact that I'm reading voltage all the way down there, computer's reading amperage on the scan tool, there's not a wiring problem here at all. This is a faulty O2. Some unplug it tests would be nice for the signal and the signal ground, the white and the blue. I'm gonna do that real quick. We'll just do key on for this. Yeah, because key on, 2.2. I'm gonna unplug this. Okay, unplug that. I wanna get a couple readings on this side. It was the top 2 wires. This is gonna be unplugged. I have done these before. I'm gonna reference some other videos I've done on widebands. And what I expect to see is a reference voltage on both the signal positive and signal negative. Okay, this one's 2.2 volts on that, which is the top left, which would have been the blue wire. Where's that coming from, guys? It's coming from the computer. Okay, there's no way that this wire is touching ground. Basically a reference voltage. This is the other wire. Read 1.7 on that one. 1.76 and 2.2 something. But what that means to me right now is wiring from computer down to this sensor is fine, and nothing's touching ground, and we're gonna put an O2 sensor in this. It's running like, on me. It's running like poo. Because I have the sensor unplugged. It's running worse with the sensor unplugged. There we go. Guess it had to go into a default mode first. All right, let's change the sensor. Ah, yeah. We got some oil on this thing, man. Want to get a shot of the sensors right there. There's your thumbnail. Yes, sir. Now, absolutely, this car should have this oil leak taken care of. Danner's gonna need to let his customer know. And we're not doing anything with that catalyst code right now. Nothing at all. Hey, two things.
Okay.
Oil leak probably should be addressed. And the other thing is it's had a catalyst code too.
I know.
Okay, so.
Yeah, but it was running so rich that cat couldn't keep up.
Oh no, absolutely.
She knows about it. I told her, I said, I don't know.
Yeah, no, that's, you know, the answer is certainly gonna be, let's get this mixture right. The other thing you might wanna do too, Danner's an oil change. How long she been driving it like this?
Yeah, she bought a new car because this one's been nickel and diming her. So I think when she brought it in, she just parked it. But she still wanted to fix it. I don't know why.
But you definitely want to sell her an oil change and then maybe look into this oil leak a little bit too, bud.
All right.
So our fuel trim numbers might not be ideal when we're done because of fuel contaminated oil. When you have a car that's running real rich like this one, that can happen. We'll see what our trim numbers look like, but absolutely, I'd suggest an oil change. All right, that's it. Let's go back up top and plug it in and see what she looks like. All right, we're plugged back in. So first thing I want to do, you see these heater malfunction codes too. That's pretty cool. That means there's, you know, circuitry involved or computer recognizes an open. I'm going to erase these codes first. I mentioned that, by the way, because that in itself can show you circuit integrity on different circuits. Like, we didn't have heater circuit codes before. Unplug the sensor, now we do. That's a pretty good integrity test for the heater circuit. But we're gonna have some data that is still there, some memory that's still there. The long-term trim is still gonna be there. And so we'll see some counter fuel trim numbers, some things that I teach you guys about here on this channel. Definitely spend some time in chapters 4 and 5 for this type of stuff. I also covered it in chapter 1. Oh, it's telling me to turn the ignition switch off, and I was ignoring it. Anytime you clear codes, you want to reread them. All right, good. No codes are there, so we go back to live data. I guess it's technically data. I've always said data. All right, AF sensor, AF lambda, short-term, long-term, O2 sensor 2. Don't need the heater current, but all right, so let's focus. Oh, we'll kind of look at all of it. Right now we're at 15%, 0.15 on the short term. That guy right there is 15%. Long term is at 1, so it did reset. It's chugging a little bit momentarily. Short term just went positive 47%. That's not good. Downstream is full lean right now, totally different than what we had. I mean, we did just start it. I haven't given it any fuel yet. Raising the RPM right now. I don't like that the short term is positive 47%. Downstream's full lean. It is possible that we have maybe a vacuum leak here. Let me raise the RPM more. It's also possible that sensor is not fully warmed up yet. We are dropping. We're down to 30%, 28%, 27, 26. It is dropping. A little bit different reaction than I expected with the long term. I like a lambda of 1. I don't like that percentage though. Let's watch it. It just stalled on me. So there's a memory in here that's a little bit different than what I'm used to looking at. You know, we're back at 47% again on the short term. I really feel like I need to wipe this memory. It's coming down. We fixed this car. Just the memory's just a little bit different than what I'm used to seeing. You see the downstream's like showing 0.02 right now. Upstream is showing me a minus 3.5 milliamps. Oh, what just happened? Where's my short term? Why did I deselect that? Yes, I don't like that. Why are we so high? I feel like we have like an actual lean condition. Let's graph this upstream sensor. See if we can drive it rich and lean. So our full lean went down to minus 2.15 milliamps. Let's see what I can drive it to. Oh yeah, I drove it all the way up to 1.69 milliamps. Okay, I drove it up to 2.2 and then minus 2.9. That upstream sensor is absolutely working like it should be. I don't like my trim numbers. Well, that range is definitely not accurate. The minus 1.4 that we talked about before up here and positive 1.4, because I was able to drive it, as you can see, 2.26 rich and minus 2.19 as far as the signal goes being lean. So that's about a 4 milliamp range. Exactly what I was talking about. The exhaust smells clean. I mean, me revving it like that's gonna stink a little bit. Does not smell like it did, but I still have a short-term fuel trim that's 35%, which I'm not liking. Let's see what it does. Hold my RPMs up. It's like it had a memory of the short term. Seeing a little bit of the min-max up and down of that signal. It doesn't move much. Still at 23%, 22%, it's coming down. %35 at idle. Let's see if I can clear the fuel trim memory. Nope. Special functions. ECM, PCM reset. Yes. Now, is that going to reset the trim? I like that it maintains that with the data. Watch our trims. Yeah, man. It was immediately up to 47%. We have another problem with this car. O2 is the fix. We fixed the O2. Downstream's no longer full rich. There's your downstream, but it's showing lean. Upstream, we can merge. The graph merge is cool. And bank 2 sensor, or sensor 2 downstream. I don't like it, Caleb. Definitely still have our rich lean activity going on, even though it's a wideband. It's just in the really milliamp range, microamp range almost, you could call it. And you see really the activity on that downstream is not good. I mean, that cat is definitely, it's gonna be a problem. Let's see what other data I can look at. Down to 18%, it's 1.18, 18% on short term. Just gonna go look real quick and see if we have any vacuum hoses off. Haha, dumbass. Check this out. Yeah, it was my fault too, because I probably leaned on that. Mass airflow's right here. It didn't look like a vacuum leak either because it didn't really get much better. Yeah. When I raised the RPM, so this makes sense that, I don't know, no, this was not me. This was left off. I don't think I did that. Couldn't be you. I mean, it definitely could have been. All right, nice. I was like, oh, come on. Is it the cat? Is it, look, it's climbing again, but I'm at like 16%, not 30%. Let's raise the RPM now and look at it. Yeah, we're still more positive than I would like to be at this higher RPM.
Where do you want to be at?
Plus or minus 10% total trim. Right now we're at 3% long term, 20% short term at this higher RPM, like 2,500. And then at idle, see where we're at, It's much better at idle. So that's suggesting potentially a dirty mass airflow sensor. I mean, it's got 177,000 miles on it.
Yeah.
Or no, we're back at 20%. I mean, that could certainly be a MAF issue. I should probably look again and make sure that there isn't something else unplugged. It's better. I believe this is gonna end up with a cat code again too, by the way. Just there's so much activity in this downstream sensor. You know, as you guys are looking at this, the blue traces are wideband upstream. I'm at like 19%, 20%. At around 2,500, still climbing. Yeah, about the same. At idle too. Let's have a look. See if we don't have something else that was left off or knocked off by me. We can do an unplug it test to the mass airflow. It stalled it. Just want to see what it runs with default with the MAF unplugged. See what our trim numbers do. Yeah, it's like full rich on the AF sensor, 2.3 milliamps. That's like full rich right now. Or is that full lean? Yeah, it was full rich. Oh yeah, we're like 0.69. That's minus 69% fuel trim with that unplugged. That wasn't really helpful at all. I'm not saying that that's not contaminated. We have something else still, in my opinion. I mean, this could be maybe need to be driven and the cat kind of cleaned out. Let's clear codes, because I know I set some. Trouble codes not detected. We made the right call. I'm just really addressing another issue.
Well, that's what I was gonna ask. So like, I don't know, charging wise, like if they only came in for that problem, would you just stop?
No, it's a great question. So what Caleb said is, what do you do charging a customer like this? Well, this is something that you couldn't know. With a completely dead upstream O2, you wouldn't know what other problems there are. The only problem that you would encounter in something like this is the same thing we're looking at right now can reset the P0171 code. So you're kind of, in this scenario, you need to have some other idea of what's going on before you just say, I need more money from you, Mr. or Mrs. Customer. Sometimes, you know, you get the bear and sometimes the bear gets you. Look, that's much better now. I mean, some runtime was probably necessary. I'm showing 5% on the short term right now. Let's go take this for a ride. One of the things you definitely don't want to do with a case like this is get too involved without going and taking it for a ride, especially when you have relearning of adaptives going on, and some cars will not relearn properly unless you test drive it. The other thing too is when you clear the memory, there's a relearn process too. It didn't look like I was able to clear the trim numbers, but these are things you want to think about. Yeah, I see this changing around a little bit. I'm at like 15%, 14%, 13%. I'm not too concerned about the 171 code coming back anymore. That looks a lot better. Let's see what it looks like at 2,500. Oh yeah, 15, 16, 17. That's at 3,000. Definitely don't like the activity still of this downstream O2. So, you know, some questions you guys may have. Wideband sensor, do you still have a rich lean factor going on? Yes, you do. You can clearly see it on the downstream sensor. It's just a much smaller number when you're talking about the AF sensor itself. You know, people would look at that and be like, look, it's not moving. I myself included in the past, but it really is. Let's zoom in on that axis a little bit, or the scale. And you can see the up down of that sensor, and you see the downstream mirroring it. I think it's possible that our positive numbers short term could be related to the cat. This is going to set a 420 code. So what we warned the customer about is exactly that. All right, yeah, I don't think a test drive is needed. We're sitting about 5% right now on the short term, 7%, 8%. There's 12, 13. 14, 16, 15, 12, 9, 8. Yeah, we'll let this go. That's a fix. Finally, we have a little bit of straight line cat data. That's good. Let's raise the RPM one more time, watch it. A little more activity on the cat than I want to see. Nothing we're going to worry about for this. This is Danner warning his customer about that 420 code potentially coming back. It does look like it's improving. I'm seeing longer periods of time where that line is flat. My trims I'm happy with, 10% on the short term, -3 on the long term, so 0.97. would be -3% is how you'd read that. And balance those out, it puts you around 9% total trim at that RPM. I'm good with that. Don't like the cat. And I just want to watch the idle again for a minute. We're -3 still in the long term on the idle. And we're bouncing around. There's 9%, 10%, 12%, but take away the -3 for the long term. That puts you right there too. This is good. Oh, we have been running this in the shop, by the way, and it's nice and clear, yeah.
So.
Oh, and some of you might be thinking, well, Danner, you mentioned fuel contaminated oil. Well, that's right. Fuel contaminated oil because it was running so rich, but what's that gonna do to your fuel trim numbers? It's gonna give you negative trim numbers, not positive. So I'm not too worried about fuel contaminated oil. That is not what we're looking at here on these slightly elevated trim numbers. I'm not gonna worry about this. That looks a lot better on the cat at idle for sure. Nice little flat line there. I think a test drive for this and these numbers will improve even more. Calling this a fix. I don't think there's anything else we need to do. Guys, thanks so much for joining us. I hope you learned something. Spend some time in my chapter 4 and 5 playlist. I know that I don't have wideband sensor tests specifically listed in my book, but I do talk about this stuff that we went over here and how to use the same tests that we've been doing for narrow bands on checking to see if the sensor's lying, enforcing rich, enforcing lean, and looking at fuel trim data, and looking at your tailpipe emissions too is what we did on this car. So all relevant info. Final comment here at idle, 0.94 on the long term. I'm showing that's gonna be a -6%, and then short term is 0.12 positive or 12%. Balance those out, where are we at? 6% total trim, perfectly fine with that. We're gonna warn this customer about the cat and oil leak and all that stuff. And we appreciate you guys so much. Caleb, thanks for being here. And we'll see you guys next time. Do we wanna mic him while we're here? Okay, but a grumpy Danner could make for good footage.
Get away from me there, snot stream.
No, that's not stream. It does smell like butt. It is not a pleasant smell in here. It has a water leak smell to it. You're a butt leak.